Assalamu alaikum. In this video, I will talk about equations and inequalities, which is part 2.2 and 2.3 of chapter 2 Math 111 قسم العلوم لطلاب السنه التحضيريه بجامعه الامام عبدالرحمن بن فيصل بالدمام. Okay, so in the beginning we will talk about the quadratic equations, معادلات الدرجة الثانية. Quadratic equations, معادلة الدرجة الثانية. Okay, so definitions. Quadratic equations. A quadratic equation in X is an equation that can be written in the standard form. This is the standard form of the quadratic equation. You can see that the degree of these equations is 2. That's why we said quadratic. Okay, so quadratic and equations, because as you can see, this is equality. We have the equal sign over here. So we have here one side equal another side. So this is the equations, and it is a quadratic because we have a power 2, or the degree of this part is 2. Also, we have A and B and C. A and B and C are all real numbers, and A does not equal 0, because if A equals 0, that means we will not have this part. This part would be cancelled. Then we will have this one left, which means this is not quadratic. This is linear equation, which we talked about already last week. So the A does not equal 0 because we want the x squared. We want this x squared because we are talking about here the quadratic equations. Okay, now how can we solve the quadratic equations? The first method of solving the quadratic equations is by using the factoring. We already talked about factoring in chapter 1. Now, how can we use factoring to solve the quadratic equation, or why we use the factoring? We use the factoring because we want to reach the zero product properties. The zero product properties means that if we have two factors, okay, the product of these two factors equals 0, so either the first one equals 0 or the second one equals 0, okay? Because if the product of two numbers equals 0, one of them has to be 0, either the first one or the second one. Okay, so now how can we solve these equations? By using the method factoring, okay? So first things, we will put all the numbers or all the terms in one side. So we go in to put this 5 in the other side, or we subtract 5 from both sides. So we will have x squared minus 4x minus 5 equals 0. Now we will factorize the left side. So we gotta look for two factors. The product of them equal 5, and the sum of them equal negative 5, and the sum equal negative 4. The two numbers would be 1 and negative 5. If you times 1 times negative 5 would be negative 5, and 1 plus negative 5 would be negative 4. So this is the two factors that I'm looking for. So we will write them x minus, in this form, x minus 5 times x plus 1 equals 0. So since here we have two factors, the product of these two factors equals 0, so either the first one equals 0 or the second one equals 0. Now we will solve each one separately. When x minus 5 equals 0, it means x equals 5. When x plus 1 equals 0, means x equal negative 1. So the solution set is negative 1 and 5. So let's see how can we solve this one. We will factorize this side. We'll factorize this side. So x, then x equals 0. So what the two numbers that the product of them equal 18 and the sum equals 7? Let's see. We can have, for example, 9 and 3. 9 times 9 times 2, or 18 times 1. Okay, now I will go with 9 and 2 because if I add 9 with 2, I will have 7. Now, since this is negative, that means one of the factor is negative, the other one is positive. And since here is positive, that means the large number is positive, which is 9. So here 9, here 2. Now, two factors, the product of two factors equals 0, means either x minus 2 equals 0 or x plus 9 equals 0. Now, in this case, x equal 2, and in this case, x equal 9. This one is just a linear equation, so we can solve it just by adding 2 to both sides. So x equal 2, and same things with x plus 9. Okay, so the solution set would equal 2 and 9. Sorry, here negative 9. 2 and negative 9. Okay. Okay, here we have another equations. 3x squared equal 4x. As you can see here, we have only two terms. So the same things here, I'm going to put both terms in one side. So 3x squared minus 4x equals 0. Now, I can see that I'm going to factorize the left side, but as you can see, I have only two terms. So I can take a common factor, which is x. So I take x as a common factor, so I left with 3x from the first one and negative 4 from the second one. So this equals 0. Now, same things, I have two factors. The first one, this is the first one, and this is the second one. The product of them equals 0, so either the first one equals 0 or the second one equals 0. So either x equals 0 or 3x minus 4 equals 0. Okay, so I can solve this to find out x value. So x would equal 4 over 3. So I'm going to move this to the other side, 4. Then I will divide by the coefficient of x, which is 3. So x equal 4 over 3. Okay, then we can write the solution set, which is 0 and 4 over 3. Okay, we have here another example, 4x squared equal 5x. So the same things, I have two terms. I'm going to put them in one side. So 4x squared minus 5x equals 0. The second step is to see what can I do with the left side. So it's obviously that I can take x as a common factor. So I'm going to left with 4x minus 5 equals 0. Now, two factors equal 0. So either the first one equals 0 or the second one equals 0. So for this one, I'm done. But for this one, I have to solve it. This is a linear equation. So x equal 5 or 4x equal 5, then x equal 5 over 4. Okay, so the solution set is 0 and 5 over 4. Okay, using the square root property to solve the quadratic equation. So now we have the quadratic equations that can be solved by using the square root properties. What is the square root properties? Let's see, we have this form of the equation. Ax squared plus c equals 0. As you can see here, we don't have the term of x, just the x squared and the constant. So in this case, I will use the square root properties, which means I will put the x squared by itself in one side and the other numbers in the other side. Then I will write x equal plus or minus the square root of a. Let's see how can we do that with this example. So as you can see, I want x squared by itself in one side, so I will divide by 9 both sides. Okay, so x in this case, or x squared, equal negative 27 over 9. Now I will take the square root of both sides. So I'm going to take here the square root, and here's the square root, plus and minus. So x would equal plus and minus the square root of negative 27 over 9. Now you know that the negative sign can be this one. The negative sign can be out of the square root with I. Okay, so I'm gonna bring it out of the square root and replace it with I. Okay, so I'm gonna replace this one with I, and this would be the answer. Now also you know that 27 is divisible by 9, because 27 is 3 times 9. So I'm gonna just cancel this 9 with this 9, so I will left with x equal plus or minus I times the square root of 3. So we have two solutions, negative I root 3 and I root 3. So the same things maybe with this, we can follow the same strategies with these equations. Let's solve the first one. So I have y squared minus 121 equals 0. So as we said, we have the terms of y squared and the constant. So we gotta use the square root method. So I'm gonna move this to the other side. So y squared equal 1 to 1. Now I will take the square root for both sides, so y equal plus or minus the square root of 1 to 1. And you know that the square root of 1 to 1 equal 11, so y equal plus or minus 11. And this would be the answer. Okay, for the second question, y squared equal plus 27 equals 0. So I'm going to move this to the other side, so y squared equal negative 27. Now I will take the square root for both sides. So the square root here and the square root of here. So I'm going to have y equal plus or minus the square root of negative 27. Now the negative can be out with I, the square root of 27. Also, 27 can be written as 3 times 9. So plus or minus I, the square root of 3 times 9. 9 can be out of the root with 3. So this one would be plus or minus 3i root 3. Okay. So the solution set here is 3i root 3 and negative 3i root 3. Okay. Let's see the last one, which is x minus 1 square equal 25. So we have the whole terms here square, and here we have a constant. So we can directly take the square root of both sides, square root here and square root of here. So we're going to have x minus 1 equal plus or minus the square root of 25. You know the square root of 25 is 5, so I will replace it with 5. Now I have two options, okay? Either x minus 1 equal 5 or x minus 1 equal minus 5. In this one, x equal 5 plus 1, so x equals 6. And in this one, x equal negative 5 plus 1, so x equal negative 4. So the solution set would be 6 and negative 4. Okay. Okay, now we have how we use the quadratic formula to solve the quadratic equations. So in case you are not able to do the factoring, or to use the square root method, or to use any of the method that we take previously, you can always choose this method. Okay, you always can choose this method, which is the quadratic formula. The quadratic formula give you the solution directly. So x equal negative b plus or minus square root of b square minus 4ac over 2a. Okay, so be careful to do the division all over this part. Okay, this is number one. Number two, what is b, what is c, what is a? So a is the coefficient of x squared, and b is the coefficient of x, and c is the constant. Okay, so this is the formula, or the quadratic formula. The term inside the radical, which is the b squared minus 4ac, is called the discriminant. So this value is the discriminant. What's the benefit of the discriminant? Okay, so when the discriminant is positive, it means that the quadratic equations has two distinct real solutions, or real root. So we have two different solutions if this is positive. So if we just compute this value and see that this value is more than 0, okay, this value is more than 0. Let's see, this is d, the discriminant. So if the discriminant is positive or more than 0, that means we have two solutions for our equation. If the discriminant equals 0, so it means we have only one solution, or a double or repeated solution. That means we have two solutions but the same value. So it is actually only one solution. And if it's negative, so d is less than 0. So we have also two solutions, but in this case not real, they are complex. So we have two complex roots. Okay, so now let's see, here we want to use the discriminant to find the nature of the solution. يعني إيش طبيعة الحل, the nature of solution. What is the nature of solution? Is it, is d, so if d, we gotta compute d. So to see if d is more than 0, that means we have two distinct real solution. If d is 0, it means that we have only one solution. If d is less than 0, that means we have two complex roots. Okay, so let's see, for example, for the first one. Okay, first things you have to just identify what is a, what is b, what is c. As we said before, a is the coefficient of x squared, so a equal 2. b is the coefficient of x. Be careful to take the number with the sign behind before it. Okay, and c is the constant, which is negative 1. Then you have to just compute b squared minus 4ac. This value, as I said, it is the discriminant. So when we compute b squared, which is negative 5 squared, minus 4 times a, which is 2, times c, which is negative 1. So we have a 25 minus with minus is a plus. 4 times 2 is 8. So 25 plus 8 is 33. And as you can see, it is positive or more than 0. So since the discriminant is positive, so in this case, we can tell that the solution or the equation has two distinct real solutions. The equation has two distinct real solutions. I mean, we have two solutions. If we solve this equation, we will see that we have in our solution set, we will have two different values. Okay, let's see the second equations, which is 4x squared plus 4x plus 1 equals 0. The same things. We will identify what is a value. A value is the coefficient of x squared. B is the coefficient of x. C is the constant. Now we will compute b squared minus 4ac. So b squared is 4. So 4 squared minus 4 times 4 times 1. So 16 minus 16, which is 0. So we found that d equals 0, which means we have only one repeated solution. One repeated real solution. Okay. For the third equations, we have 3x squared plus 2x plus 3 equals 0. So in this case, we have a value equal 3, which is the coefficient of x squared, b equal 2, which is the coefficient of x, and c equal 3, which is the constant. Now we compute d value, or the discriminant. So it is b squared, which is 2 squared, minus 4 times a, which is a 3, times c, which is the 3. So we have 4 minus 4 times the 3, 12. 12 times the 3 is 36. So 4 minus 36 is minus 32. So the value is negative here, which means the equation has two non-real complex or conjugate solution. So if we solve this one, we will see that here we have only one solution. And for this one, we have two, but complex. That means we will have I. Okay, this is complex, this is real. Okay. Now let's do the same things with this exercise. The first equations, 3x squared minus 4x plus 1. So we have to find what is a. As you see, a is the coefficient of x squared, which is a 3. b is the coefficient of x. Take it with the sign, negative 7. And c equal the constant value, which is 1. Now, b squared, the discriminant, is b squared minus 4ac. So the first one would be b squared, so negative 7 squared, minus 4 times a, which is a 3, times c, which is 1. So we have 49 minus 12. So 49 minus 12 is more than 0. As you can see, this is bigger than this one, so the value would be more than 0. You don't have even to compute this value. All what you have to do is to just to know whether it is positive or negative. So since this is positive, it means we have two real solutions. Two real solutions. Okay? Okay, now let's see if we have second question. This one. So in this one, I will just erase. So the same things, I have to recognize what is A. A is 9, B is 12, C is 4. So the discriminant is 12 squared minus 4 times 9 times 4, which is 144, minus 36 times 4, 36 times 4, so 24, 4 times 12, 14, so also 144, which equal 0. So in this case, since the discriminant equals 0, it means we have one real solution or one repeated solution. Okay. Okay, let's do the third equations. So same things, we want to know what is A, what is B, what is C. A here is 3, B is 2, and C is 1. So the discriminant B squared, which is 2 squared, minus 4 times 3 times 1. So 4 minus 12, which is, it is a negative 8, or you can directly say that this is less than 0 because this one is bigger. So it would be negative. It's negative 8, which is less than 0. So we have two complex solutions. Two complex solutions. Okay, so again, if it's less than 0, you would have two complex solutions. So you have to just revise those three statements. The first one, two distinct real roots or solution, one real root two natural complex roots. Okay. For this one, we have how to use the quadratic formula to find out the solution. Okay, so we already talked about how to find out the value under the root, which is this one. So all what you have here is just to apply this formula. The formula is x equal negative b plus or minus square root of b square minus 4ac all over 2a. So just to substitute the values of a, b, and c in your formula, then you just compute, simplify to get the final answer. Okay, let's do this example over here. So directly when you see the question that asks you to solve an equation, you can use the quadratic formula, and here the question also asks to use the quadratic equation. So the quadratic equation, the quadratic formula. So the quadratic formula is minus b plus or minus square root of b square minus 4ac over 2a. So first, what is a, what is b, what is c? A is 3, b is 5, and c is negative 2. Now let's substitute the values over here. So negative b, which means negative 5, plus or minus the square root of b square, so 5 square, minus 4 times a times c over 2a, so 2 times 3. Now, negative 5 plus or minus the square root of 5 square is a 25 minus and minus. So as you can see here, minus and minus will be plus. 4 times 3 is 12. 12 times 2 is 24. Okay? Over 2 times 3, which is 6. Okay. So now we have negative 5 plus or minus the square root of 49 over 6, and this would be negative 5 plus or minus 7 over 6. Okay, so I'm going to write it over here. Negative 5 plus or minus 7 over 6. So I have two solutions, one with the plus and the other one with the negative. So either negative 5 plus 7 over 6 or negative 5 minus 7 over 6. In this case, I will have 2 over 6, which is 1 over 3. And in this one, I would have negative 12 over 6, which is negative 2. So the solution set is 1 over 3 and negative 2. Okay. Okay, same things. We're going to use the quadratic formula here to find out the complex roots. So in this case, as you can see, the value under the root or the discriminant is positive. Okay, that's why we have our solution set is two real solution. Now in this one, we can see here that after we applying the formula, we have a value, a negative value under the root. So which means I would have two complex here. This is the first solution. And the second solution, we can write it as you can see here, or we can divide it to two solutions. The first one is 1 plus I root 2, and the second one is 1 minus I root 2. So as you can see, we have two complex solutions. Why? Because the value under the root is negative. Okay, let's see this question over here. We have 2x squared plus 3 equal to x. So the first things I will bring everything in one side. So 2x squared minus 2x plus 3 equals 0. Then I'm going to find what is A value, what is B value, what is C value. So you can't find A, B, C unless you put the equations in the standard form. Okay? Now A equal 2, B equal negative 2, and C equal 3. So the formula says that x equal negative b plus or minus the square root of b squared minus 4ac over 2a. So let's just substitute the value in the formula. So we have negative, which means positive. So I will have here positive 2 or 2 plus or minus the square root of b squared. So negative 2 squared, negative 2 squared is 4. So 4 minus 4 times 2 times 3 over 2a, so 2 times 2. Okay, so 2 plus or minus the square root of 4 times 2 times 3 is 4 times 2 is 8, 8 times 3 is 24. So 4 minus 24, 4 minus 24. And 2 times 2 equal 4. So the value under the root would be negative 20. So 2 plus or minus negative 20 over 4. Now the negative under the root can be, we can write it I. Okay, so 2 plus or minus I root 20. Root 20 is 4 times 5. The 4 would be out with 2, and the 5 will remain. So I'm going to have here 2 plus or minus 2i root 5 over 4. Okay, so also I can also simplify this one to be, I can take these two as a common factor and then divide it by this 4. So I would have here 2, then 1 plus or minus I root 5 over 4. Then I can cancel this one, and I will left with 2 in the denominator. So I'm going to have 1 plus or minus I root 5 over 2. This is the solution. So I have two solutions. The first one is 1 plus I root 5 over 2. And the second one is 1 minus I root 5 over 2. Okay. So in conclusion, we have this is the standard form of the quadratic equations. We write it as ax squared plus bx plus c equals 0. And we use, to solve these quadratic equations, we use factoring, we use the square root method, and also we use the quadratic formula. This is the quadratic formula, and we also learned that the value under the root, which is this one, is the discriminant. And from the discriminant, we can recognize the natural of the solution, whether it is 2 real solution or 2 complex solution or 1 real solution.